right, so we're going to do some more kinematics examples here. And in this example, I'm giving you the velocity function, and what I'm asking you for right here is how far it has traveled. That means I want the displacement. So remember, like I said the other time, you've got to remember what's going on with this. All right, if I'm giving you the velocity and I'm asking you how far, that means displacement. That means you're going to anti-differentiate. So it doesn't tell you to do that, but you've got to figure it out. So we're going to be getting the displacement function from here, which means anti-differentiate. So the displacement function is S of t, and I'm going to anti-differentiate this one. And remember what we do, we add 1 to the exponent and divide by that new exponent. So that's negative 3t, add 1 to the exponent, divide by that new exponent, add 1 to the exponent, 9t squared, divide by that. How we anti-differentiate a constant, it's just plus 12t, and then always, remember, we cannot find that constant term at the end, so it's plus c. And now what I'm going to do is clean this up a little bit. These can simplify. I can take out those 3's and I get negative t cubed. This can't really simplify, so I'll just leave it as 9t squared over 2 plus 12t. And now I'm going to stop. Remember, I solved for that constant. I substitute a value in, a point on the curve or something, and this information right here is crucial. The object starts at the origin when t equals 0. Because of that, that tells me that the point that I'm using is 0, 0. And that also tells me that that constant of integration will be 0. If it didn't tell me that, if it gave me some other information, I would have to substitute some other point in for s of t and solve for that c, like we did in previous lessons. Hopefully we remember that. But because it tells me this, the origin is 0, 0, so that means my constant of integration is going to be 0, so I don't need to put anything after that. You don't need to put a plus 0. All right, so after 2 seconds, that means, after 2 seconds means t equals 2, and I substitute it into my displacement function. So s of 2 gives me negative 2 cubed plus 9 2 squared over 2 plus 12 times 2. And when I work all this out, this gives me negative 8 plus 18 plus 24. I should get 34 meters here. Okay, so after 2 seconds, it's traveled 34 meters. That's what its displacement is. And let's take a look at the next one. Okay, next one. When's the object at rest? What does that mean? That means the velocity function is equal to 0. So you see this object at rest, and you think that, set that equal to 0. Well, it gives me the velocity function up here. So I'm going to set it equal to 0 and solve for t. When means what is the time? Okay, that's what when is. Time equals what? So this question right here, that's what it means. We substitute 0 for v of t. And now I'm going to solve for t. And even without a graphics calculator, it's not too bad because I can factorize out a negative 3. I can factorize out a negative 3, and I get t squared minus 3t minus 4. And I'm running out of room here. And this guy does factorize. Okay, this expression right there. What multiplies to get to negative 4 and adds to get to negative 3? That would be negative 4 and positive 1. T minus 4 and t plus 1. Okay, because negative 4 times 1 gives me negative 4, and negative 4 plus 1 gives me negative 3. Okay, so my solutions are t equals 4 seconds, or t equals negative 1 second. And for practical purposes, we'll take off the negative 1 seconds and just say it's 4 seconds. So just correction there. Those should be in equal signs right there. Sorry about that. Okay, so let's look at one more question about the acceleration, and then we're good. Okay, so our final problem here, what's the acceleration of the object? Well, first of all, that means we need to find the acceleration function. And once we do that, we substitute 1.5 in for t, and we are good. Okay, well, here's the velocity function. There it is. And how do I get the acceleration function? Do I differentiate or anti-differentiate? I'm going to differentiate to get one more there. So won't forget the equal sign this time. Here it is. So remember how I do that? I multiply by the power and take 1 off the power. So this is going to be negative 6t plus 9. And I'm not doing any constant because I did differentiation. And now I substitute 1.5 in there. And I get negative 6 times 1.5 plus 9. And at 1.5 seconds, my acceleration is 0 meters per second squared. And what does that mean? It means that particle is moving at a constant, and we'll assume it's in a straight line, so I'm going to say speed instead of velocity, moving at a constant speed. It's not speeding up or slowing down, because remember, if my acceleration is positive, it's going to be speeding up, and if my acceleration is negative, it's going to be slowing down, and that's what it means. Okay?